All right, so let's look at part two. Continuing with number 8. They give you data here. They say the length of time it took a random sample of 32 former smokers to quit smoking permanently are listed. Assume the population standard deviation. They gave you sigma again. 6.1. They gave you N32. Alpha is 0.05. Is there enough evidence to reject the claim that? Here goes your claim. The mean time it takes smokers to quit permanently is 14. Mean time is what? 14 years. What do you guys hear in the claim? You should say the null. Is. That's your claim. So the alternative is mu different than 14 years. Okay, so let's look. What's going to be the choice here? Should be C. Okay, should be that. Now we're gonna put this in the calculator. You're gonna go to Stat Edit, and we're gonna pull this in L1. Okay, that's the first thing you need to do. Stat Edit. We put that in L1. Okay, so you need to put the data in L1, just like this. There goes the data in L1. Once you put the data in L1, then you can move from there. Okay, you need to put the data in L1. Then you go to Stat Test. It's a z-test. How do I know? I have sigma that's known. I have a large sample. And I have any population. I know it's a z-test. So now, input is data. Mu 0, we said 14. Sigma is 6.1. The data is in L1, and then it's different time. So here we go. Here goes the setting. Here it is. So this is your setting. And everybody should know why that is the setting. Simply because there goes your mu 0, there goes your sigma that you know, there goes your data, and there goes your two-tail test. All right, so when you press calculate on this, you get Z is 1.66, p-value 0.097. That's what you get. Okay, that's exactly what you get. And there goes your answers. That's it. Here we go. Once you have that, then you can make a decision. You compare the alpha to, so this guy is greater than alpha. So you're going to fail to reject the null. You're going to fail to reject the null. So there is not, no. If you fail to reject the null, then remember where your claim is in the null. So there is sufficient evidence to support or to fail to reject the null. There is not sufficient evidence to reject the claim. Yeah, it's D. So if you're failing to reject the null, it means that you don't have enough evidence to reject it. So there is not sufficient evidence to reject the claim. Yep, that's it. That's D. All right, that's 8. You guys will do 9 on your own. Let's look at 10. 10 is the rejection region method, right? It's still data. So you're going to go to Stat Edit. Put this guy into, I have it in L2, right? It says, a weight loss program claims that the program participants have a mean of at least 11. At least, a mean of at least. At least means greater or more. Yeah, at least, yes, like this. See, it has an equality in there. So this is the claim, and this is the null. HA is going to be less than. Voilà, that's it. You work for a medical association and are asked to test this claim. A random sample of 30. Assume the population standard deviation is 4. Right? Alpha is 0.08, and they give you data. You have everything you need. Hmm? HO and HA. So HO and HA, let's go ahead and look at it. There it is. D is the answer. Now, what's the critical value? Now, this is a left tail test. So if this is a left tail test, how do I know? Look at your alternative. This is a left tail test. So it means that my Z stat for sure is going to be negative. This is a left tail test. Less than 11, yeah? Alpha is right here at what? 0.08. So this guy is inverse norm, 0.08. That's going to give me what I'm looking for. So second function, DISTR, inverse norm, 0.08. Left tail test. So this guy is going to be negative 1.4. Round to two decimal places. Negative 1.41. All right, left tail test. It's a left tail test, left tail test. Yep. The choice should be B, left tail test. So let's start with the first picture. This one is finding my critical value. You could use your table at any time you like. You can use your normal table. There goes inverse norm. And the other thing is finding the Z statistic. So you put the data first in stat edit. My data is already in. So let me show you where my data is at. My data is right here. It's in L2. Just so we are all on the same page. My data is in L2. Okay, you can put your data in L1, wherever you like. You can even put it in L3. Okay, my data is already in L2. So now all I'm going to do is go to stat, test, Z test, and I have data. Mu 0 is 11, sigma is 4, the list is L2, and now this is a less than test. So here we have it. Let me show you my setup. There goes the setup. Okay. There goes our setup. And then you press calculate. Once you press calculate, there goes what you get. Now let's talk, shall we? This is it. Look, this is your Z stat. And there goes your p-value, okay? Z stat p-value. My Z stat is negative 1.75. There goes the Z stat, okay? Negative 1.75. This is number 10. Negative 1.75. Now, since negative 1.75, the ZC is negative 1.41. It's right here, negative 1.41. So negative 1.75 is going to be somewhere here. So since that Z is in the rejection region, you're going to reject the null. Yeah? So we pick A. All right? So you're rejecting the null. And remember, the claim is in the null. So you're rejecting the claim, really. So at the 8% significance level, there is enough evidence to reject the program's claim that the programs that I have a mean weight loss greater or equal to 11 pounds. Or equal to 11 pounds. Okay, here it is. That's that. This is what we have. That's number 10. That's 10. 11 you can do on your own. 12 you can do on your own. 13 you can do on your own, finding critical values. Let's do 14 really quickly. State whether the standardized test statistic indicate that you should reject the null hypothesis. Okay. So there goes your critical values. I hope everybody sees that. So I'm going to do this in green. This guy's going to be in purple. This one is going to be in black. And this one is going to be in hot pink. Okay, let's start with the green. Negative 1.992. Where is it? Negative 1.992. It's going to be somewhere here. Okay, so if it's fall in the rejection region, then you reject the null because the t-stat is less than. Does that make sense? So reject because the t-stat is less than negative 1.914. Let's go to the purple one. 1.862. 1.862 falls somewhere here. So if it falls somewhere there, then it's outside of the rejection region. So we're going to fail to reject the null because that t falls. Fail to reject because the t is within the non-rejection region. I hope that makes sense. Yes. Let's go to the black one. 1.934. 1.934 should be somewhere here. 1.934. It's in the rejection region, so we're going to reject the null because that t is greater, right? It's greater than the critical value. Okay. And finally, the hot pink. Let's go look at the hot pink. Negative 1.4. Negative 1.944. Negative 1.944 is somewhere here. It's even before that green one. Negative 1.944. You still reject, right? You still reject because it's less than negative 1.914. Reject. Here it is. Okay. All right, people. This is 14. Okay. There goes 14. Yes. That's 14 for you. Okay. 15, you do it on your own. 16, let's see what's up with 16. Now, look, this is a t-test, and we're going to talk about why. Why? Normally distributed population, sigma is unknown. This is key. Even if your n is big, because somebody can say, oh, my n is large, but you don't have sigma. Careful. These are the two key things. Normal distributed population, sigma unknown. You use a t-test. I need everybody to remember this. T-test. So test the claim. They gave you mu less than 4715. So mu 4715. That's how it should be. So therefore mu, this sign, and then mu less than, right? This is it. Now we're going to go to stat, test, t-test. Stat, test, t-test. You have stats. Your mu0 is 4715. X bar is 4917. S of x is 5501. N is 53. And it's a less than test. So this is how you put it together. Make sure it's a t-test. If you put z-test here, it's not going to work, people. Make sure you have a t-test. I gave you the conditions. All right, once you calculate, our results are right here. So there goes the result for the t-test. Okay. Now, t-statistic, round to two decimal place 0.2 7. 0.27. P-value is 0.605. Okay. Now, decide whether to reject or fail to reject. The p-value is too big. It's big. It's bigger than alpha. So you're going to fail to reject the null. So we fail to reject the null. And then where was the claim was in the HA. So if we fail to reject the null, then what are we going to say? There is the claim was in the alternative and we failed to reject. So we failed to reject the null. So there is not enough evidence to support the claim. Yeah. There's not enough evidence to support the claim. There is not enough evidence at the 10% significance level to support. We can't support the claim because we're failing to reject the null. That's what we have. Remember where your claim was in the alternative. So if we fail to reject the null, we cannot support the claim. All right, 17. Okay, let's do 17. So a used car dealer says that the mean price of 3-year-old sports utility vehicle is, so that's a two-tail test. Mean is, so mu different than, your claim is in the null. You suspect this claim is incorrect. You find, so your N is 25 similar vehicle with a mean price of 22,846, standard deviation. This is S. Why? Because it comes out of the sample of 25. Is there enough evidence to reject the claim at 0.10? Now, assume the population is normally distributed. So normal population, I need everybody to notice, sigma is unknown, N is 25, small sample. Remember this. Okay, so where is my HOH, A, F? We start there. Okay. Now, critical values, there are going to be 2 because it's a two-tailed test. Yes. Alpha, you split it in half. So that's going to be alpha over 2, alpha over 2. So this is 0.05, 0.05. There goes TC. ETC. Now, how do we find TC, people? It's inverse T. You're going to put area to the left and degree of freedom, which is 24, n minus 1. That's how you do that. Second function, DISTR inverse T. Area to the left, 0.05. Degree of freedom, 24. So this guy is negative 1.71 comma 1.71. Round to what? 3 decimal places? If it's 3 decimal places, then it's going to be negative 1.711, 1.711. Let me show you what I have here. That's it. Remember, two-tail test, you split the alpha in half. I shouldn't say it over and over and over and over. You should be tired of me saying that. All right, so your critical region or rejection regions are going to be to the left and to the right of that TC. So our choice should be B, negative 1.711 and positive 1.711. All right, the T stat, we need to go to stat, test, T stat. We have stat, so we enter the information. So mu 0 is 22,000. X bar is 22,846. S of X is 1949. N is 25. This guy is different than. Okay, so this is what we have. These are our results of a t-test, people. Make sure you wrap t-test, t-test, t-test. T-test. I'm gonna go to the setup. Here we go. So T is 2.17. Okay, so now where does that T falls? Let's take it in green. 2.17, where does it fall? This guy, 2.17, 2.1. This one is 1.711. This is negative 1.711. 2.17 falls here. So the T star falls within the rejection region, so we're going to reject the null because the tested disease is in the rejection region. A. Reject the null because text is in the rejection region. So at the 10% significance level, we reject the null. The claim was in what? The null. At the 10% significance, there is sufficient evidence to reject the claim that the mean is, it should be B. We reject the null. That's that. Y'all can do 18 on your own. 19 is the p-value. You can do it on your own. 20, same thing. It's all t-test. Be careful. Put the data in, find the stats. Let's see. Let's do 21. A car company says that the mean gas mileage of its luxury sedan is at least 21. Mean gas is at least. So mu is greater or equal to 21. Mu is less than 21. So this guy is HO, this is HA. This is the claim. Now, you believe the claim is incorrect. You find a random sample of 6 car, N is 6, with a mean mileage of 18 and a standard deviation of 2. At alpha equals 0.05, test the company's claim. Assume the population is normally distributed. So I have normal population. I have sigma is unknown. And I have n equal to 6, small sample. This should be a t-test. So I should use a t-test because, use a t because population is normal sigma, nope. This is it. I should use a t-test, why? Because population is normal sigma is unknown. That's why I should use a t-test. This is what you should pick. Now, when you have that, then let's look at the hypothesis testing. So it's this guy. All right, so let's go use the t-test, stat test. T-test, stats, mu 0 is 21, x bar is 18, s of x is 2, n is 6. This is a less than. And then we calculate. So here we go. We have all that we need here. For the t-test. Make sure it's a t-test you pick. There goes the t-test. So your standardized test statistic is negative 3.67. Critical value, it's a less than test. So negative TC. All right, alpha was what? 0. What? 0.05. Okay. So this is inverse T, 0.05. Degree of freedom is 5. DF is 5, which is 6 minus 1. So you go to inverse T, 0.055. So my critical value is negative 2.015. That's the critical value. Here we go. There goes my critical value. Use inverse T, you get your critical value. Now, let's see where everything falls. So this guy is negative 2.015. All right. Let's look at standardized test statistic, negative 3.67. So it falls within the rejection region. So we're going to reject the null. Reject the null at, and what was the claim? The null. So we rejected. So at the 5%, there is sufficient evidence to reject the car company's claim that the mean mileage is at least. So this is it. So notice that you had to figure out what to use, which distribution to use. You have to look at your conditions, people. This is key. Normal population, sigma is unknown. That's the t-test. Always. Always. Well, that's it. So you guys go ahead and review chapter 7.2, tonight. And we shall see each other next. Please check your syllabus. Good night.